Hello, my dear friends, and welcome back to my channel. Now it's time to do or learn chapter number 3 of your class 9 maths, and that is coordinate geometry. Right? Now, what is coordinate geometry? This is a new branch of mathematics for you, right? So, we will see. Now, ever you wondered how can Google Map finds your exact pinpoint location? So, there is a coordinate geometry behind it, right? So, we are going to learn the basic concepts of coordinate geometry in this lecture. Now, from where or when this branch started? Now, in 1600s, there was a famous French mathematician whose name is René Descartes. Now, one fine day, he was just laying on his bed and chilling, and he saw a fly that was buzzing around on the floor, or sorry, on the ceiling, right? So he got a question that how can I give the location of this fly at any point to the other person, right? He got a question that how can I get the location of this fly at any point. So he has done some research work on it, and finally he invented a new branch of mathematics, that is coordinate geometry. Right now, coordinate geometry is a branch of mathematics that builds bridge between algebra and geometry. Right now, if we see that if I want to tell coordinate geometry in simple words, it is just a address of every single point. Right now, we will see when this coordinate geometry is useful in real world. So you can see it in GPS and mapping, computer graphic and games. If you see the BGMI, in BGMI, if you want to find the location of your or your teammates, you can see in the map, right? Now in engineering and architects, we also use coordinate geometry. In aviation industry, it is based on coordinate geometry itself, right? Now back to that question of the René Descartes. This is a fly that is buzzing around this ceiling, right? This rectangle box is a ceiling. Now, if I want to tell a location of this fly, what it look like if I just say that the fly is on the ceiling? Isn't it very helpful, right? So I have to give a precise location, because by just saying that fly is on the ceiling, that means other person have to look at the whole ceiling and have to find the fly, right? Now, what if I have another method to tell a location? And the method is, what if I just do a partition of this whole ceiling into equal parts, small equal parts, right? Small parts with equal areas. Here you can see these all have equal areas. So I have just did a partition of this whole ceiling into a small parts with equal areas. So now my fly is buzzing around in this box. So I just have to tell other person that fly is buzzing around in this box. Now to do that, I have to name all the boxes, right? So you can name all the boxes. Let's say for this row, I will name it as B1, then B2, then B3, then B4, and B5. And this is B6. So I just have to tell other person that fly is in the B5 area. So the person will look only in the B5 and he find the fly, right? So from this method, by just saying that fly is on the ceiling, this method is more precise and more useful, right? So this is the first method to tell a location more precisely, right? Now, what if I want to give a more precise location than this? So we have another method, and in another method we are going to use a distance, right? A distance of fly from the sides. What I am saying is, let me just give a name to each side of this rectangle. Let me name it as A, B, C, and D. Right now, this is not looking like D. A, B, C, and D. Right now, if I want to find or if I want to give a location of this fly, exact pinpoint location, what I am going to do is I will find a perpendicular distance of this fly from two sides of this rectangle. Let's say perpendicular distance of this fly from this side of rectangle is this, right? Perpendicular distance, that means I have to draw this. Now let's say perpendicular distance of this is let's say 10 centimeter, right? This is 10 centimeter. Now let me find a perpendicular distance of this fly from this side A and B. So let me draw a perpendicular here. So if I find a perpendicular distance of this fly from this side A and B, let me say this distance is, we can say 13 centimeter, right? 13 centimeter. Now, if I want to tell location of this fly by these two distance, I just have to say that fly is at a perpendicular distance of 13 centimeter from side AB and 10 centimeters from side BC. Now, the person will find exact location of fly from these two criteria, right? There will be only one point that satisfies these two criteria, that the fly is at a 13 centimeter distance from side AB and 10 centimeter distance from side BC, right? So we go to another method. This method is more precise and give exact pinpoint location of any point, right? And in this method, we get area, small area in which the point is, right? So by this method, we are going to solve exercise 3.1. Now, here is our first question. How will you describe the position of table lamp on your study table to another person? The question is, how will you describe the position of table lamp on a study table to another person? We have just learned in our example, we have a fly in place of table lamp, and a study table, we have ceiling, right, is a study table. So, we are going to use a distance method to give a location, exact precise location. So, let me find the location of this lamp from the sides. Before that, let me give a name of each side. So, it will be easy to us to describe. Let's say I have named all the side as A, B, C, and D. Now, after naming it, I have to find the location of this lamp from two sides, from one smaller side and one larger side, right? So, let me draw a perpendicular here. This is a perpendicular. I have to find a perpendicular distance, right? So, I have mentioned 90 degree. Now, these two sides are a distance of the lamp from side BC and DC. Now, let me guess the distance. You can write distance you can write any number as a distance, right? There is no bound, but you have to look at the figure. Here you cannot write smaller distance and here bigger distance, right? So I have to write, let me think, this is a 10 centimeter. So I have to write something 7 centimeter here because it is look proper in this figure, right? Now, once you find the distance of this lamp from these two sides, so I just have to write the answer. I just have to tell the other person that the lamp is at distance 7 centimeter from side DC and at a distance 10 centimeter from side BC, right? So it is my easy answer. So in your answer, you have to write that find a distance of lamp from side BC and DC. Now let's say distance are 10 centimeter and 7 centimeter. So your answer will be, so location will be location or position, right? You can write in any format. Let me write 10 and 7, or you can write 7 and 10, whichever format you want to choose, right? See, here we have drawn a figure and we have named each side, right? A, B, C, and D. So I have to mention that this is a location distance of the lamp from side BC and DC. Now, if you don't name the sides of this rectangle, then you just have to mention that a distance of lamp from a smaller side and a larger side, right? So this is a very easy answer. Now we will see second question. In the second question, we have a street plan, right? A city has two main roads which crosses each other at the center of the city. Now these two roads are along with north-south direction and east-west direction. They are saying that in the city there are two main roads and the crossing point of these two roads are the center of the city, right? So one road is going to north-south direction and one is east-west direction. Now all other streets of the city run parallel to these roads and are 200 meter apart. Now there are 5 streets in each direction. Using 1 centimeter is equal to 200 meter. Draw a model of the city on your notebook. Right? So I have to draw a model of the city on my notebook. And here they mentioned that represent the road and street by single lines. So my first step is there are 4 directions in the city: north, south, and east, west. So let me mention it first. This is north, this is south, this is west, and this is east. Right? After this, there are 2 main roads. One is going to north, south, and one is going to east, west, and they are crossing at the center point of the city. Right? So I have to draw a true line, 2 lines that is representing a 2 main roads. One is in north south direction, so I have done this. Now one is in east west direction, so I have done this. Now these are 2 lines, so let me draw an arrow, so it will become a line, right? Now they are crossing at the center point of the city, so let me just mention here this is the center of the city. Now if you see in the question, they told us that there are 5 roads in each direction, and all the roads in the same direction are parallel to each other and 200 meters apart. Right? So I have to draw 5 roads in each direction parallel to each other and 200 meters apart. But in our model, we have 1 centimeter equal to 200 meter. So let me mention here 1 centimeter equal to 200 meter. By this scale, I have to draw 5 roads. So let me draw first one. 5 roads or 5 streets, right? So here is a first road. Now to parallel this, I have to draw another road. Now here I have third road, and here I have road number 4. Right? These 4 are roads. Let me draw an arrow because they are told us to represent road or streets by line. So these are 5 roads in north-south direction. Now there is a 200 meter distance between 2 roads. So in your notebook or in your drawing of your model, you have to take care of that. The distance between these 2 roads must be 1 centimeter in our model, right? Distance between these 2 roads will be 1 centimeter for our model, and all the distance between all the roads will be 1 centimeter, right? Now there are also 5 roads in east-west direction, so I have to draw another 4 more. So let me draw it. This will be first, this will be second, this will be third, and it will be 4, right? Let me draw an arrow. So it is very easy, right? We have just represented all the streets. Now it is our model. So in the drawing the model, we have to mention that is 1 centimeter equal to 200 meter. That is a scale of our model, right? In our model, if there is 1 centimeter distance, that means in real life there is 200 meter distance. Now there are 5 roads in each direction, so we have 5 roads in each direction parallel to each other, right? 5 roads in east west and 5 roads in north south. The center point of the city is a crossing of the 2 main roads. So we have the center point of the city, right? Now if you see, the question is there are many cross streets. Now what is cross street? Cross street is a particular cross street is made by 2 streets, one running in north south direction and another in east west direction. So they are just saying that there are many cross street. And what is cross street? Cross street is simply a circle, right? So you can see here, if a street running in north south direction crosses a street in east west direction, there will be a cross. So it is a cross street, right? So there are many cross street in our model. You can see here, these all are cross streets. So let me so these are cross street, right? Now each cross streets is referred to a following manner. So before writing this, let me name all the streets. So this will be my first, second, third, fourth, and fifth street in north south direction. And here let me write 1, 2, 3, 4, and 5. 5 street in east west direction. Now if you see, if I want to refer a particular street, or if I want to give a name the particular cross street, what it will be? if the second street running in north-south direction. What is the second street that is running in north-south direction? It will be this street, right? Second street running in north-south direction. And fifth street in east-west direction. What will be fifth in east-west? The fifth street in east-west direction will be this, right? If they both crosses and make a cross street, you have to name it as 2, 5. You can see here, it is mentioned in our question. You have to name it 2, 5. So let me see where it both the street crosses each other. So here is the point where both the street crosses each other. So if I want to name it, or if I want to refer this cross street, I have to name it as 2, 5. So the particular convention to naming a cross street is, in the first you have to do a bracket in which you have to write two numbers. In the first number will be a cross street, first number will be street number of north-south direction, and second number will be street number of east-west direction, by which if they both street crosses each other, they make a cross street. So name of that cross street will be a street passing through that point in east-west, north-south direction will be my first number, and east-west direction will be my second number, right? Let me give you an example. What if I want to name this street? What will be name this cross street? What will be it? So I have to draw a two bracket here in which I have to write two numbers between, and there is a comma between them, right? Now, first number will be a street that is passing through this point in north-south direction. So in north-south direction means this direction. Which street is this? It is a street number 4. So I have to write 4 here in the first number, and the second number will be a street that is passing through this point in east-west direction. So this is street number 2 that is passing through this point. So I have to write 2 here, right? Very simple. So by this manner, I can name all the streets. It is a convention, so I have to only use this method, right? Now, let me erase all unnecessary things. Right now, if you see a question, how many cross streets can be referred to as 4, 3? So I have to find how many cross street can be referred as 4, 3. So 4, 3 means fourth street in north-south direction, right? So which street is fourth number in north-south direction? It will be this. Now second number, that is third street in east-west direction. So which will be third in east-west direction? It will be this red one, right? So these both street crosses each other at this point. So I can name this point as 4, 3. Very easy, right? Now the question is, how many cross street can be referred as 4, 3? So if you see in this whole model, can you find another cross street which is referred to 4, 3 or which is named 4, 3? No, right? So there will be only one cross street with each numbers or with each coordinates, right? So my answer will be only one. So let me write it. For the first question, my answer will be only one. Because they asked us how many, right? Second question is, how many cross streets can be referred to as 3, 4? Now we have 3, 4. So 3 will be third street in north-south direction. So which is a third street in north-south direction? Is this red one. Now 4. There is a fourth street in east-west direction. So it will be fourth in east-west direction. It will be this. Now this both crosses each other at this point. So I can name this point as 3, 4. So let me just write 3, 4, right? Now, is there any other cross street that can be referred as 3, 4? Absolutely no, right? So answer of this question will be also only one. So you can see here, 4, 3 is not equal to 3, 4. So in coordinate geometry, order matters, right? Order matters. So we will use, or we will remember this sentence there. In coordinate geometry, order matters. Now, after learning this, let us go to the basic terminologies or basic concept of the coordinate geometry that we are going to use in this. Now, remember that in this chapter, only in this standard 9 of coordinate geometry, we are going to learn only 2D concepts, right? Only 2D surfaces. So we are going to learn only 2D, right? Now, the two number lines. So if there is a number line, we have already learned what is number line in chapter number 1, right? Now here is my number line. I have 0 here, all positives here, and all negatives here. So if I want to name this number line, because it is a line only, so to any line I can give a name, right? Let me say this is a line. So I can give a name to the line. I have named it as x dash, right? So by this way, I have a number line here, simple number line. I have named this as x dash. This is a horizontal line, right? So we will call it x axis. You have to remember this. A horizontal line is equal to x axis, right? Horizontal line is equal to x axis, and the name of this line is the notation will be x and x dash, right? You have to remember this also. Into the horizontal line, we will call it x dash. X will be a positive direction, x dash will be a negative direction, and we will call it x axis, right? Why we are remembering this? Because it is a convention, right? In all the world, all the people will use this notation and these standards only, so there will be no confusion, right? So we have remembered the name as x dash, x axis, right? Now I can move my point to left and right in this number line very easily, right? I can find a distance, or I can do anything with my point in left and right direction. What if I want to move my point in upward and downward direction? So I cannot do this in this number line. So let me just rotate this number line with respect to 0 in a 90-degree anti-clockwise. So it will be look like this, and this is a vertical line, this will be horizontal line, and this will be vertical line, right? So this is a vertical line. All the rules that is applying on this number line will also apply on this number line. The only difference is it is horizontal and it is vertical, right? Now, if you see here, I have named this line as y dash. Y will be a positive direction, y dash will be negative direction. You have to remember it, and you have to use this notation only for the positive direction of vertical line. You have to name this as y, and negative will be y dash. Now, we will call this vertical line at y-axis. What? Y-axis. So you have to remember this. We have x-axis and y-axis. Now you can see I can move my point upwards and downward direction in this line. Now what if I combine this both line such as they will coincide at a point zeros of both the line, right? I will combine these two number lines such that they crosses at the point 0. Now after doing that, so you can see here, this is my horizontal line, that is x-axis, right? X and x dash, I have named it positive direction x, negative is x dash. Now this is my y-axis, positive direction will be y, negative will be y dash, right? Simple. Now, if you see, they both are coinciding at point 0. So 0, that is origin, right? We will remember this. The point where two number line crosses each other at the zeros, it is the origin. What it is? It is the origin, and we denote it by O, not a 0, right? We will denote it by O. You can see here where axis intersects, denoted by O, right? Now, if you see, these two lines is cutted down whole area in 4 equal parts, right? They just do a partition of this whole area in 4 equal parts. Now this is my first part, this is second part, this is third part, and this is fourth part. So if you see here, I have given a name of each parts. So you have to remember these names also. So first part will be quadrant 1, right? Second part will be quadrant 2. Third part will be quadrant 3, and fourth part will be quadrant 4. Now you have to remember the names of these all quadrants in this direction only, in anti-clockwise, right? I have named it as 1. Now this will be my second anti-clockwise, this will be third, and this will be fourth. So you have to remember this, right? Now, what is a quadrant? Quadrant means 1/4, right? So here we have 4 equal parts of 1. So I have named it as a quadrant. So you have to remember that this is a quadrant, right? Now, after learning this, if you see any plane means not the plane in which you are going fly, right? Plane means a surface for our chapter. So in any surface, if the surface has axes and quadrants, then we can call that surface a Cartesian plane. What I am saying is, this is a surface, right? This is a simple surface. In this surface, I have 2 axes and 4 quadrants. So this surface can be called as Cartesian plane. Why Cartesian? Because the name of that French mathematician is René Descartes. So from that, Cartesian plane, right? So formal definition will be A plane consists of axes and the quadrants. This is a plural form of axis, right? Axis and the quadrants. We call the plane Cartesian plane, or we can call it coordinate plane, or we can call it XY plane. Why XY? Because there are two axes, X and Y, right? Now, the axes are called coordinate axis. Very simple. So, to which plane you can call the Cartesian plane? If the plane consists of axes and quadrants, right? So it is very easy, right? Now we will see finding a location of a point. So before that, let me tell you how can we describe a location in coordinate geometry. See, coordinate means, if you have seen a Fast and Furious 7 or Mission Impossible or any other film, they represent it. Let's say this is a New York City, and New York City, in besides that they write a point. Let's say northeast direction and 42 degree 55 minutes and 42 seconds. Let's say these are the location points, right? So this is a coordinate to describe any location in our globe, right? So this is a method, right? So in coordinate geometry we have also a method to describe a location of any point. And what is this method? So to describe a location of any point in coordinate geometry, let's say you are describing a location of any point. Let's say I am describing a location of this point. So I have to describe in this manner only. I have to do a bracket of this. Let me say name of this point is P, right? So I have to find the location of P, or to describe the location of P, I have to do a bracket. In bracket I have a comma, and I have to write two numbers. One for here and one for here. Right? Now what are that numbers? Let's say their number are 2, 5, or you can write 1, 4, according to the location of that point, right? Now we will find that how can we write these numbers. Remember this, your first number will be your x coordinate. What is it? X coordinate, right? So let me write x coordinate for the first number. Your first number is x coordinate. Let me write it here, x coordinate. And what will be your second number? Second number is your y coordinate. So here, let me write, it is your y coordinate. So you all get the method to describe a point, right? Or to describe a location in the coordinate geometry. We have to do a bracket in which I have to write two numbers. My first number will be my x coordinate, and my second number will be my y coordinate. Now this whole bracket, we call it a coordinates of a point, right? This whole bracket we will call it a coordinate of a point. What we will call it? Coordinate of a point, right? Now how to write numbers? So there will be also a method. So I have to learn that how to write a numbers. So let me write, or let me do a point here. Sorry, let me do a point here only, not here, right? So I have a point here. Now if I want to write the coordinates of this point, that means I have to draw a bracket in which I have a comma, and I have to write two numbers. Now what will be the numbers are? So you have to look at the x-axis from the point. If you look at the x-axis from the point, this is my point and this is my x-axis. So if you look at the x-axis from the point, they will cross at point 2, right? And if you look at the y-axis point, 2, then I have to write 2 here in the first number, is the first number, right? Is the x coordinate, right? Now for the second number, you have to look at the y-axis. So this is y-axis. Now if you look at the point, look at the y-axis from the point, it will coincide at 1. So I have to write 1 here. Very simple. Let me give you another example. Let's say I want to write a location of this point, right? So to find the location of this point, see, this is all is drawn on the graph paper, right? The graph paper will look like this. So I have drawn all this in graph paper, so I can find location or I can find distance easily. Now if you see here, if I want to name this point, what will be name of this point? So let me just write a bracket here, and in which I have to write a comma. Now for first one, you have to look at the x-axis. So from the point, if you look at the x-axis, this is my x-axis, right? So if I look at the x-axis from the point, it will coincide at -4. So I have to write -4 here. Don't forget signs. You have to mention whichever sign there is, right? Now, if you look at the y-axis from the point, it will be your second number. So if I look at the y-axis from the point, it will coincide at 3. So I have to write 3 here. Just simple as that, right? Let me write location for this point. To describe coordinates of this point, I have to do a bracket. In bracket, I have to write two numbers, right? So for the first number, I have to look at the x-axis. Wherever, no matter wherever your point, you have to write, or sorry, you have to look at the x-axis from the number from the point to write first number, right? So I have to look at the x-axis, and it will coincide at -3, right? You can see here. So I have written -3 here. Let me draw it. Now, for the second number, you have to look at the y-axis. So let me look at the y-axis from this point. So it will be -3 again. So my coordinates will be -3 and -3 for this point, right? Same way you can describe coordinates of any point. See, this is a trick or a short method to describe coordinates, right? It is not a definition of coordinate that you have to look at this point or this axis from the point, right? It is a short trick to describe a location of, describe a coordinate of any point. Now let us do the example here, last example. If I want to describe a coordinates of this point, for the first one, I have to look at the x-axis. Now from this point, if you look at the x-axis, it is 3. So I have to write 3 here. Now for the second one, I have to look at the y-axis from this point. So if I look at the y-axis from this point, it is -1. So let me write -1 here. Very easy, right? So you can see here, I have mentioned the coordinates of points in each quadrant, right? I have taken example 2, 1 in quadrant 1, example -4, 3 in quadrant 2, -3 in quadrant 3, and 3, -1 in quadrant 4. So if you analyze it, you can see here, in each quadrant, you can see that for the first quadrant, your coordinates will be in the form of both positive. You can see here, I have 2 what? In any point in this quadrant, if you write a coordinates, it will be only both positive, right? Why? Because it is in the positive direction of y-axis and positive direction of x-axis, right? All the numbers or all the points in this quadrant are positives. So you get both positive coordinates. Now if you see in the second quadrant, you can see here I got first negative and second positive. Why? Because first number will be number from x-axis, and x-axis is negative in this quadrant. So my first will be always negative and second will be always positive because it is a positive direction of y. So in quadrant 2, it will be always negative then positive, right? So you have to remember this also, right? It will be asked in your MCQ or 1 mark question. What will be the format of coordinates in quadrant 2? So you have to mention it as minus plus. In quadrant 1, plus plus. Now if you look at the third quadrant, both are negative. Why? Because it is a negative direction of x-axis and negative direction of y-axis. So I have to write both negative. You can see the example -3 and -3, right? Now in the fourth quadrant, x direction is a positive. So first one will be positive and y direction is a negative. So second will be negative, right? So this is a simple trick. So we have learned what are the axes, what is the origin. You can see here. Now what is a Cartesian plane? Cartesian plane is formed by axes and quadrants. What are quadrants? What is the name of each quadrant? Quadrant 1, 2, 3 and 4. Now then, how to write a coordinates or how to describe a coordinate in coordinate geometry of any point. So we have to do a bracket in which we have to write two numbers. First number will be number from x-axis. Second number will be number from y-axis. First number we call x coordinate. Second we will call y coordinate. Right? Now in each quadrant, what will be the format of coordinates? In first, it will be both positive. Second, with first negative, second positive. Both negative and positive negative. Very easy, right? So now we will see example that is mentioned in your textbook, right? See, this is writing of the coordinate. I have told you that you have to look at the x-axis from the point. This is a simple trick, right? The formal definition of x coordinate and y coordinate will be from the distance. Now what I am saying is I have taken this photo from your NCERT. Now if you look at here, they drawn this graph in graph paper, and here if I have point P. So if I want to write coordinates of point P, how it will look like? So for the first coordinate or x coordinate, I have to look at the x-axis from P. So if you look at the x-axis from P, it will be 4. So I have to write 4 as first coordinate. Now for the second, I have to look at the y-axis. So it will coincide at 3. So I have to write 3 here. Very easy, right? Now if you see a first question, that is perpendicular distance of a point P from the y-axis. Perpendicular distance of point P from the y-axis. Y-axis, that means this axis, right? So I have to find this perpendicular distance of point P from y-axis measured along with the positive direction of x-axis. So measured along with the positive direction of x-axis. That means I have to measure this distance with this positive direction of x-axis. They are saying that I have to find a distance of Pn. It is a perpendicular distance of a point P from y-axis only, right? Very easy. Now Pn will be equal to On. You can see in the graph Pn equal to Om, right? Pn, this distance will be equal to O and M. Very easy, right? So if I find the distance of OM, it will be equal to Pn. Now what will be the distance between O and M? This is a number line, you can see here. So distance will be 1 unit, 2 unit, 3 unit and 4 unit. Very easy, right? So distance between OM, that is 4 units. So distance between P and N will be 4 unit also. So I have written here 4 unit. You can see here, right? This is a 4 units, right? Now if you compare this 4 with your coordinates, you can see my x coordinate is 4 unit, right? That means I can say that. X coordinate is a distance of point from y axis. Don't confuse with ax and y. X coordinate, that means distance from y axis, right? You can see here, this is my x coordinate, that is 4, right? Now 4 is a distance of point P from y axis, right? So for x coordinate, it is a distance of point from y axis. Now same as what will be the distance of point P from this x axis, right? So let me erase all this. Now if you see this, the second question is perpendicular distance of a point P from x axis, right? Perpendicular distance of point P from x axis. So if you see here, this is point P and this is x axis. So it will be perpendicular PM, that is already drawn in the question. This will be perpendicular distance, right? So if I have to find PM, in the question they mentioned that measured along with the positive direction of the y axis. That means this is a positive direction. So PM will be equal to ANO, right? You can see in the figure itself also, right? You can visualize also that PM will be equal to ANO because it is drawn in a graph paper, right? So if I measure the distance between O and N, it will be equal to P and M, and it will be my answer of the question, that perpendicular distance of point P from x-axis. So distance between O and N is 1, 2 and 3 units. So PM will be 3 units, right? You can see here I have written the 3 units. So C is my y coordinate. So my y coordinate is a perpendicular distance of point P from x-axis. So if you are mentioning y coordinate, that means it is a distance of point P from x-axis, right? Don't be confused. Y coordinate, that means distance from x-axis. X coordinate, that means distance from y-axis. You have to take care of the sign or take care of the direction also. If it is in positive direction, you have to write positive number. If it is in negative direction, you have to write negative numbers. Let us see it by point Q, right? If I write coordinates of point Q, what it will be? First one I have to see at the x-axis, right? So from Q, if I look at the x-axis, it is -6. So I have to write -6 here. Now from Q, if I look at the y-axis, it will be -2. So I have to write -2 here, right? Very easy, -6 and -2. Now, if you see there, a perpendicular distance of point Q from y-axis, perpendicular distance of point Q from y-axis. So I have to find distance between Q and S. You can see this is a perpendicular drawn from Q to y-axis, right? This is y-axis. So I have to find distance between Q and S. Now in the figure I can see that QS will be equal to RO. right? So I just have to find a distance between R and O, and it will be 1, 2, 3, 4, 5, and 6 units. If you see, distance always comes in positive numbers. So I have written 6 units. But if you see here, I have written -6 in x coordinate because it is measured along with negative direction of the x-axis. You can see here it is negative direction of x-axis, right? So in coordinates you have to write negative numbers if it is measured in the negative direction. You have to write positive numbers if it is measured in positive numbers. But your distance will always come in positive numbers, right? Now if you see, I have if you see, my question will be, what will be the distance of point Q from y-axis, from x-axis? So it will be this distance only, R and Q. If I want to find the distance of Q from x-axis, it will be only R and Q. Now if you look at here, O and S, OS will be RQ. So distance of between O and S is 1 and 2 unit only. So I have written 2 unit here, but it is measured along with negative direction. So I have written -2 here. So your coordinate will be positive or negative, but your distance will be always positive, right? So from this, what is x coordinate of a point? If I write a point here, this is x and this is y. This is my x coordinate, this is my y coordinate. X coordinate is a perpendicular distance of point P from y axis. So for x, I have to find a distance from y axis, right? Now for y, I have to find a distance from x axis. This is my simple answer. It is my x coordinate, it is my y coordinate. I have written only here. Now coordinates means the pair of number xy that I have already told you. Now what is abscissa? You can see abscissa. Abscissa is nothing but a fancy name of x coordinate, right? If I have written x and y here, you can see here that if I have written x and y here, so x will be my abscissa, right? Just simple as that. Abscissa is only a x coordinate. And what is ordinate? Not a coordinate. You can see here ordinate. Ordinate is y only. So y coordinate will be ordinate and x coordinate will be abscissa. Just simple as that. And there is a crucial rule, and that is order matters in coordinate geometry. 4, 3 is not equal to 3, 4, right? I have already told you that 4, 3 is not equal to 3, 4, right? So we have learned what is abscissa, what is ordinate, what are coordinates, how to write coordinates, what is x coordinate, what is y coordinate, right? And what will be the format of coordinate in each quadrant. So after learning all these concepts or all this terminology, let us go to the examples. It is our example number 1, and the question is, I have taken this photo from NCERT textbook only, right? The abscissa and the ordinate of the point B are. What is abscissa? Simply x coordinate. What is ordinate? Simply y coordinate, right? So abscissa and ordinate of point B are. Where is point B? So here is our point B. So let me write the coordinates of point B in the bracket. I have to write 2 numbers. First number will be, I have to look at the x-axis from the point B. So it will coincide at 4. So I have to write 4 here. Now for the second number, I have to look at the y-axis. So it will coincide at 3. You can see here, right? So I have to write 3 here. Now abscissa, that means 4 x coordinate. So I have to write 4 here, and ordinate is 3. So I have to write 3 here, right? And the coordinates of B are simply 4 and 3 in the bracket. Very easy. Now x coordinate and y coordinate of point M. Question is same but asked in different language. Here they used the word abscissa and ordinate. Here is a x coordinate and y coordinate of point M. So here is our point M. So let me write the coordinates of point M. I have to look at the x-axis. You can see here it is in second quadrant. So my first x coordinate will be negative and y coordinate will be positive for this, right? It will look like this, negative and positive in second quadrant. So if I look at the x-axis from the point, it coincides at -3. So I just have to write -3 here. It coincides at 4 for y-axis. So I have to write 4 here, -3 and 4. So I can just write the x coordinate of M is -3 and y coordinate is +4. And the coordinates are -3 and 4. So much easy, right? Now third one, x coordinate and y coordinate of the point L. Now where is point L? Here is our point L. So if you look at this point, if I write the coordinates of the L, if I look at the x coordinate from L, it is -5. So let me write -5 here. If I look at y coordinate for y axis from the point L, it is -4. So let me write -4 here. Now just write the answer. That is L, x coordinate of L is -5. X coordinate of y coordinate of L is -4, and my coordinates are -5 and -4 because it is in the third quadrant. So I have written -5 and -4, right? Both are negative. Now, fourth, x coordinate and y coordinate of point S. Here is our point S in fourth quadrant. So if you look at this, if I write coordinates of S, it will be, look at the x-axis, it is +3 only. So I write +3 here. If you look at the y-axis, it is -4. So I have to write -4 here. So x coordinate is +3, y coordinate is -4, and coordinates of S are 3 and -4. So much easy, right? This type of question is will be asked in your exam. So take care of this. Example 2: coordinates of the points marked marked on the axis in figure. I have taken this figure from the NCERT textbook. We have A, B, C, D, and E, 5 points. So let me write all the points here first. A, B, C, D, and E. Now to write the coordinates of all these, I have to make a bracket and comma, bracket and comma, bracket and comma, bracket and comma, bracket and comma. Now, if you see here, what will be coordinate of A? Where is point A? I have here point A. Now, for the point A, if you look at point A, for first one, I have to look at the x-axis from the point. So point A itself on the x-axis. So if I look at x-axis from the point, it is +4 only, right? The point at which A is lying. So it is +4 only. So I have to write 4 here in place of x coordinate, right? Because for the first one, I have to look at the x-axis and the point itself on the x-axis. Now, if you look at the y-axis from the point, where it will coincide. So this is my y-axis, right? So if I look at the y-axis from the point, it will coincide at this 0, right? So I have to write 0 as a y coordinate because it coincides at 0, right? So this will be my first coordinates for the point A, 4 and 0. Now second one is B. Where is B? Here we have B, right? So if you look at the x-axis from this point B, if you look at the x-axis from this point B, it will coincide at, you can see here, if you look at the x-axis from this point, it coincides at this 0, right? So I have to write 0 in x coordinate. Now, if you see for the y coordinate, you have to look at the y-axis from the point. So if you look at the y-axis from the point, point itself is on the y-axis. So I have to write the point itself, that is 3, right? So I have written 3 here. Now, this is my coordinate for B. Now we will see for C. Where is C? Here we have C. It is on the x-axis. So if I look at the x-axis from the point, it is itself. So -5 here. So in the x coordinate, let me write -5. Now if I look at the y-axis from the point, it will coincide at 0. So let me write 0 here. Where is E? Now for point D. If I look at the x-axis from the point, it will coincide at 0. Right? You can see here. If I look at the x-axis from the point, it will coincide at here 0. So let me write 0 here. Now for the y-axis, if I look at the y-axis from this point, the point it itself on the y-axis, so that is number -4. So I have to write -4 here. Very easy, right? Now for the point E, where is point E? Here we have point E. Now if you look at the x-axis from this point, point is itself on the x-axis. So I have to write 2/3. Here you can see point is on number 2/3, right? Now, if I look at the y-axis from the point, it will coincide at 0. So I have to write 0 here. So by this example, you can take a analysis that if your point is on x-axis, here you can see my A point is on x-axis, E point is on x-axis, and C point is on x-axis. So my A, then C and E, these three points are on x-axis. So in these 3 points, you can see that the y coordinate is 0. If you look at these 3 points, y coordinate is 0. And what is the x coordinate? X coordinate is a point on which number is itself. For a is on 4, so my x coordinate is 4 itself. C is on -5, so for C -5 itself, and E is on 2 by 3, so 2 by 3 itself, right? So for any point on x-axis, their y coordinate will be 0, always 0. What? For any point on x-axis, their y coordinate will be 0. I have written it here, right? So the coordinate of any point on x-axis, it will in the form of x0. Y coordinate will be always 0, right? Now, if you see, point B and D are on y-axis, right? Point B and D are on y-axis. So, if you look at this, you can see here, point B and D are on y-axis, so their x coordinate is 0. You can see here, right? So for any point on y-axis, their x coordinate will be 0. And what will be y coordinate? Y coordinate will be the number on the point itself. So here B is on 3, so I have written y as 3, right? So you have to remember this. For x-axis, y coordinate will be 0, and for y-axis, x coordinate will be 0. So much easy, don't confuse with it, right? Now, if you see here, let me tell you that find the distance of point A from x-axis. Now point A is itself on x-axis, that means there will be 0 distance between A and x-axis, right? So y coordinate is a distance of point from x-axis, we all know. So that's why we have written y coordinate is 0, right? So the question can be asked in this format also. What will be the distance of a point from x-axis? If the point is lying on x-axis, it will be 0, right? So you have to remember this also, this way also, right? I have written only these sentences here, that the coordinates of any point on y-axis will be in the form of 0y, and for the x-axis it will be in the form of x0, right? Because if the point is on x-axis, that means there is no distance from the point to the x-axis, right? 0 distance. So you can remember this also, it will be helpful in your MCQ and fill in the blanks. Now these are the quadrants. The format of coordinates in each quadrant, both positive, negative, 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 and positive, negative, we have already learned it. Now it's time to do exercise 3.1. Very easy, and we can do it very simply. Write the answer of each of the following question. What is the name of horizontal and vertical lines drawn to determine the position of any point in Cartesian plane? So in Cartesian plane, we draw lines, right? One is horizontal and one is vertical. So we will name it as, you all know, one is x-axis and one is y-axis. So you can write the answer that horizontal will be horizontal line equal to x-axis, same as vertical line will be y-axis. We all know that, right? Now, what is our second question? What is the name of each part of the plane formed by this line, these two lines? We all know there will be 4 parts of the plane which are formed by these two lines. So, the name of each parts are quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So, we have to just write quadrant 1, then you can write 1, quadrant 2, quadrant 3, and quadrant 4 here. I am not writing all, right? Now, third will be write the name of the point where these two lines intersect. What will be the name of point where these two lines intersect? I have told you it is a origin, right? We have named it by O, and O is origin. So we have to also remember this. Now we will see second question, and second question is, I have to write the following. I have taken this figure from NCERT textbook. Now you can see here the coordinate of B. What is the coordinate of B? Now let me find B in the figure. Here I have B, so I have to write coordinates of B. If I look at the x-axis from B, it is -5, so I have to write -5 here. If I look at the y-axis from B, it is +2, so I have to write +2 here. So coordinates of B are -5 and +2. Very easy, right? Now coordinate of C. What will be coordinate of C? Let me find C. I have C here at the end of the figure, right? Now, for C, what will be the coordinate of C? For the first one, I have to look at the x-axis. So it is at 5. So let me write 5 here. Now it is for y-axis, it is at -5. So let me write -5 here. So this will be a coordinate of C, +5 and -5. Right? So just write it. Now let me erase this. The point identified by coordinates -3 and -5. Which point is identified by coordinates -3 and -5? So let me look at the -3 on x-axis. Where is -3 on x-axis? It is here. Now -5, second way is -5. So let me look at -5 on y-axis. It is -3 on x-axis, right? Now -5 on y-axis. These both will coincide at this point, and name of this point is E. So I just have to write E here. Very easy and very simple, right? A point which fulfill these both coordinates or criteria, these both criteria, it is only point E. Now let us do fourth one, and fourth one is the point identified by the coordinate 2 and -4. Where is 2? Where is 2? In x-axis we have 2 here. Now -4 on y-axis. So -4 on y-axis will be here. So this will both coincide at point G, right? We have named G as this point. So we can identify G point as this coordinate. Now we have abscissa and ordinates. Question of abscissa and ordinate. The abscissa of point D. What is abscissa of point D? Abscissa is just a x coordinate, right? So point D, where is point D? Here I have point D, right? Now what will be the x coordinate of point D? That means I have to look at the x-axis from this point. It will coincide at 6. So my x coordinate is 6. So that is only abscissa, right? So I have to write 6 here. Now the coordinate of point H. Coordinate means y coordinate. So we have to find H. It is our H. Now to find y coordinate, I have to look at the y-axis. Now if you look at the y-axis from this point, it will coincide at -3, right? From this it is -3. So my coordinate will be only -3. Very easy. Now coordinates of point L. Where is point L? L is here, right? So I have to write coordinates of point L. Now I have told you, if the point is on y-axis, that means coordinates of that point will look like, for y-axis, its x coordinate will be 0. So 0, y. And what is y here? We have 5 here. So the coordinate of this point will look like 0, 5, right? You have to remember the format of a coordinate of a point on axis. What is the coordinate of point M? Now here we have point M. It is on x-axis. So the coordinate of the point on x-axis will be look like of the form for x-axis. Coordinate of x-axis will look like, we have y coordinate 0 and x coordinate will be x itself. So -3, 0. So coordinates of point will be -3, 0. So this is your third chapter, right? And in this chapter we have learned basic concept and basic basic terminologies of coordinate geometry. Now you have to learn this sentence also. This is mentioned in the last of this chapter. That is, if x and y is not equal to y and x, that means x is not equal to y. What I am saying is, if this is not equal, then x is not equal to y. That means, let me draw here, let's say 2 and 3 and 3 and 2. These both are not equal only if 2 is not equal to 3. So if 2 and 3 are not equal, then I can say 2 and 3 is not equal to 3 and 2. Order matters in coordinate geometry. Same as if, let's say, this is a square and this is rectangle, and this is rectangle and this is square. If these both are equal, it is given in question. If these both are equal, that means I have to write a square is equal to rectangle, right? It will only become when these both are equal. So this is a chapter number 3, and we will see again meet in chapter number 4. So thank you for watching this video.